Hello students, it's Professor Sansom again, and we're going to be talking about Experiment 4. In Experiment 4, you'll be using spectrometers like you used in Experiment 1. So you'll begin by doing Beer's Law, again, just like you did in Experiment 1. This time though, instead of using a serial dilution, you'll be doing a parallel dilution, meaning that you use the same stock solution for all of the solutions that you prepare. Because these are very small volumes, you can use graduated transfer pipettes to measure the volumes down to 1/4 of a milliliter. You want to be very careful though that you're precise. If you don't do it carefully, you can end up having inaccurate data, especially when we get to the experiment. In part 2 of this experiment, you'll be using the time tab in the spectrometry program. This one is different. You haven't used this in the other experiments, but I think it's pretty straightforward. You push record and it starts to record data over time. The important thing here is that when you mix all of these ingredients together, you're going to have a reaction that occurs immediately. So as soon as you've mixed them together, you want to invert your cuvette, insert it in the spectrometer, and begin recording data as quickly as possible, because the reaction has already started. As this reaction progresses, the color of the solution will gradually fade. That's because triiodide is colored red and it's consumed in the reaction. So you'll see that the absorbance will decrease over time. If you were to look at the cuvette outside of the spectrometer, you would see that the color is gradually fading away. When you're looking at your data, you want to be careful that you are using only the part that is decreasing. Sometimes, especially if your calibration wasn't totally perfect, your data will actually sort of bottom out and it will be flat towards the end of the time that you're collecting data. That can happen even if it's not at 0, which it theoretically should be if it's colorless. So when you're fitting your data, you want to make sure that you only select the part that is linear at the beginning. If you've done this experiment correctly, in particular measuring all of your reagents accurately when you're preparing your samples A, B, and C, then runs B and C should happen twice as fast as run A. Your TA will be able to give you some specific guidance about how you calculate all of the rates in this reaction. Make sure that you follow those instructions carefully because you will be sharing this data with the rest of the class. And if your data is off, it can dramatically affect the results that you get. This is a pretty reliable experiment, so as long as everyone does their calculations correctly, we generally get what we expect to get here for the rates of the reaction. Thank you. That's the end of Experiment 4, and good luck.